Hello, this is Mr. Taylor with the Young Engineers today. This is a brief overview from our first Little Bits lesson that was done on Wednesday. And this will be a brief recap. We went over what electrical circuits are. Electrical circuits are a lot like water, plumbing system, which water circulates. We want to look at electricity in this scenario, that it flows, it has potential where it goes from low to high potential, all right, and it's being pushed along. We're going to look at what these all are. There are three major terms that we want to be working with, and the first is voltage, and voltage is a force that pushes the current through the circuit. And for example, with water, like in this waterfall, gravity is pushing water along, okay? We can use a voltmeter to measure voltage. Most of the time, people use a multimeter, which has multiple forms of measuring tools in one. Some more information about measuring voltage. Different cells produce different voltages. All right. Scientists use the term potential difference when they talk about voltage. All right. Resistance is our second major term we're looking at. Resistance is the friction that impedes flow of current through the circuit. For example, like the big boulder rocks that you see in this image, it's slowing down the water. Resistors do the same thing, which create resistance. All right? That's our second thing we're looking at. Third is current. Current is the actual substance that is flowing through the wires of a circuit. Electrons, which are negative charged subparticles that are in atoms. So we have, as we stated, voltage, which is a push, resistance, which is holding it back, slowing it down, and the third is current, which is the actual substance. Electrical current consists of charged particles, as we said, flow through metal wires, because metal is a conductor, all right, and it flows. All right, the amount of electrical current is measured in amps, and the pressure with which it is pushed is measured in volts, just as water current can be measured in gallons /minute per minute, and water pressure can come in pounds, square inch, psi. Now we looked at this circuit. We looked at three images of these and determined which one actually would work. And you need to have the connection of the negative and positive, which would be the third one, is our closed circuit. All right. Now, when you look at your little bits, they can be deceiving. Little bits look like the energy is only flowing in one direction, but in all reality, it has this flow back to its starting point. And if you actually take a look at your little bits and examine them, you can actually see all the circuitry on them. And we'll be looking at each part of your little bits kits throughout the projects that we create at home. We have two types of circuits. The first one being a series circuit, all in a row, one path for electricity, one light goes out and the circuit is broken. Then we have a parallel circuit. Many paths for electricity, one light goes out and the other stays on. The example I used with class on Wednesday was the old Christmas lights that maybe your parents may have, or your grandparents, or a relative or friend, where if one of the lights go out, they all go out, just like in this example. And I remember having these when I was a kid, where one of the light bulbs would go out and my dad would give me what he called a tester bulb, and you would sit there and go through each one of the lights trying to test it. Now you don't have to do that, lucky for you. And we have parallel circuits that we use with these modern day Christmas lights that you see, and the lights, if one goes out, you blatantly can see because the energy can pass along here, okay? And if this one's out, it can go here and it can go here, okay? Now, looking at little bits, here is your front view This is the back view. As you can see, all the components that are made on these little circuit boards. And here's a side view where you can actually see the connection points as well as the magnetic joints that hold it together. Then what we did during class, we had about 15 minutes where this is the first time using the little bits. Everyone just experimented, and then we shared the different things that we discovered and made. Now we looked at our first project that we were going to finish on Monday, our light sensor. How do humans sense light? Provide an example. Sensor coordinate effector response framework using the human light sensor. Gives some examples of light sensors in engineering systems. And people gave a variety of answers for these, and this is some of the answers that we were looking for. Give you a moment to read that. Alright, from stimulus to response, basically we set up by comparing the eye to what a light sensor is. Alright, as you can see, we have a stimulus, a sensor, coordinator, effector, response. In this case, light, you have your eye, your nervous system, muscle, and then run, based off of seeing your wasp. Okay, and how that process is broken down. Sense of light, you can close your eyes for a second, then open your eyes and look around you. You ever wondered how you're able to see things around? How do your eyes function? Okay. Alright, light rays fall on the eye, they pass through the pupil of the eye, the iris changes the size of the pupil depending on the amount of light. It shrinks in the presence of less light and enlarges the presence of more light. If you've ever covered your eye and then held a flashlight at it and look in the mirror, you can actually see it go from pupil being your iris being very large to very small. It's kind of like when you get up in the middle of the night. Then we looked at a diagram of the human eye and broke down your rods and cones, which, as you can see, your cones see 3 major colors, and then your rods see in black and white. And then we just broke down that. Okay. Now, the sensor that we're going to be looking at is the light sensor. All right, the light sensors are made up using electronics. Electronics enable the sensor to distinguish between the different intensities of light. The light sensor does not detect colors, only brightness, also called intensity. Okay, then we watched this video clip of the first project that we are going to make. I'll pull that up. And it's a light sensor activated motor. In this case, a person tied a string with a paper airplane taped to their ceiling. You can actually attach anything you want. All right, let's go back to this. These are the parts that you're going to be using: a bright LED, a DC motor, a light sensor, and a power, and a wire. The LED is a light-emitting diode. It's a small module that puts out a big light, just like other LED modules. It's a great way to shed some light on your creations. Okay, and then we also have the schematics around here, and you can actually, these are diagrams, or like blueprints for electronics. You have your power source, which is using a 9-volt battery. All right. We have a wire, which helps extend any of your physical projects. It creates some separation so your little bits have some wiggle room to work with. Okay. This is your DC motor. DC motor, direct current motor, rotates a shaft when you send it the on signal. It even has a switch to set the direction of the rotation, which is left and right here, which basically it changes the polarity. Polarity, talking about the positive, the negative flow of energy. And it also has this D-shaped shaft, which allows you to attach things to it, which is pretty cool. And once again, you have the schematic for it. Then we have our light sensor. All right. And once again, the schematic. The things that are great about schematics is all these symbols actually tell you information. All right. And then we started going over the project a little bit. And we're going to finish this next class. All right. This has been a recap of Wednesday's webinar, our introduction to little bits. Thank you.